Alright, so this is demonstrating our final experimental setup for the OpenZmeter data analytics integration team. I guess the first place we're going to start is the OpenZmeter itself. You can see it's not powered on, so this is going to be a video that shows you how to power it on. And we just got access to all the features, so we're not entirely sure how it would work with our simulation file. So we're not going to be running the simulation, but we will show everything you need to do to get up to that point. And further consultation next semester or whenever this gets picked up again will be done through the OpenZmeter inventors. Anyways, so you can see you got several terminals on here. The GPS block, if I can focus on it, is down here on the right, and that's essentially telling the meter where it is longitude and latitude wise. Next, I want to go up here to the power supply terminal, which just has two terminals, L and N, and we've already got them connected, and I can show you. So we've got a red and a black wire connecting them. You can see them back here, and they actually go to the battery simulator module on the Doble power system simulator. Now, there are two different circuits set up for the meter because this is kind of like a standard 3-element metering type deal. So you're going to have these voltage inputs, V1, V2, and V3, or ABC, or whatever, and they are connected to this left-hand side module because that's what we set on the software as the voltage module. So the red is 1, yellow is 2, and blue is 3, and then you have a neutral, and you're tying all of the neutrals on the OpenZmeter together, forming that YY connection. So the other circuit is the current measured circuit, and the way it is wired before we go to the OpenZmeter is on this right side, because we told the software that this is where the current's going to be injected from. So the same thing's going on here. You got I1, I2, I3, IA, IB, IC, and then IN is the black wire. And I'm going to walk around. It's on the back hand side of this revenue meter, which is not powered on. It does not need to be powered on because it's acting more as a direction for the current to go. You don't inject currents directly into the meter. So you can see on the back here we've got our I1. It's actually hiding behind here, but I2, and then the blue one's I3. You got all your neutrals tied together, and they go back off of this node right here. They go back to the Doble power system simulator. And the way the meter measures it is it uses these current transducers that have a limit, so you have to be careful about what you're injecting into this circuit. The way they are set up is they have this little release handle, which opens up like that. You just put the wire inside this space in the center, and you close it down. Very careful though, you want to make sure that this source arrow is always pointed back towards the Doble, because that's the polarity that you're getting. And then there are two wires that go to them, and they connect to the plus and the minus terminals. I don't know if it's focusing or not, of each current input. So current 1, current 2, current 3. There's a current 4, but we're not using that one. We just want the A, B, and C for now. So without further ado, the other side of this, of course, is your power source that's plugged into the wall, and then you have this USB cable that's plugged into the Doble on one end and into our computer on the other. So now we just need to turn on the Doble. So you'll hear it fire up when you turn this on. And I just heard the computer detect a device connected. So we're going to go over here where I've not pulled up the software yet because I want to show how that works. But you're going to go up here to this protection suite v5.2.8. You're going to open it up. Just click whatever language and click OK. And once this gets pulled up, the first thing we're going to do is make sure, we're going to click on instrument here at the top. We're going to make sure that we're connected to the right terminal for our Doble. So the way you verify that is you just hit verify F6X connection. And you see how this went to red? Because it's verifying. Now it went to green, so it said yes, that's where we found the device. It's on COM2. If it weren't on COM2 and that turned red, you would just need to try the other ports and verify them one by one until it turned green here at the top. Okay, But the next thing we want to do is power on our meter. So the way we can do that is we can go down here to the bottom where it says battery, and based on our spec sheet for the OpenZmeter, 125 DC is within the range. It could be a little higher, could be a little lower. Just review the spec sheet before you inject a different value. 125 works perfect though if you want to use that. I'm just going to hit 1, and you can actually hear the OpenZmeter turning on and the Doble Power System Simulator powering up the battery module. So the issue right now that we're going to encounter together is that when you hold this down, and hold it down, what will happen is this is on low battery, so it's not going to power up. So I'm going to pause this video and I will unpause it once this is powered up enough to go ahead and start. Okay, so what happened is I waited probably about 5 to 10 minutes and I walked back over here and held down the button again, and now you can actually see the booting process. So it's connecting to the network right now, and then once it does, it'll give us a screen where it's actually taking measurements in real time. And I'll be able to show you, first I want to show you how we would run a simulation on this OpenZmeter using the Doble down here, but then I'm going to show you how you get to the IP that's going to give you all of your measurements and analysis and all of that, because that's on an open source deal. It'll be on any device connected to the same network, but then you have to provide some login credentials, and that will be provided to the next group of seniors that work on the project. So you can see now we're on the screen where it's actually taking measurements. So, but now we're going to walk back over here to the computer, and I'm going to walk you through what you would do if you were ready to run the simulation. We're not ready yet, but whoever does get to that stage will need to know this. So I want to go over here to test plan, or to no, I want to go to files first. Actually, yeah, so test plan, my bad. I want to go to open. Oh no, maybe not. Oh, my bad. Okay, yeah. So you do go to test plan, but you go to this drop down box and you go to transient playback and with Comtrade file. Now on this computer specifically, we have quite a few example files sent by TVA, the power quality department. So I can go ahead and open one of these up, and you're going to see it appear right here at the top of the screen. So I'm going to click here, and the first thing I want to do here is set my threshold, set my VT and CT ratios. Okay. So let me pause real quick and make sure I got this right, and then I'll show you how it's done. Okay, another thing I should mention is that there is an actual folder on this computer that's under desktop, and it's called OpenZmeter. That's the file path, and it's going to include all the Comtrade files, but it's also going to include screenshots taken by Akram that show us exactly how to do all this stuff. So here's a screenshot he took and labeled for us setting the CT and VT ratios. It looks like 200 to 1 for CTs and 2000 to 1 for voltage. So I'm just going to go in here, primary values is where we're going to set these up at. So 200, 2000, 2000, 1000, and 200, 200. And that makes sense if you look at it, because you can actually see your sources right here. So that's what you're setting these thresholds for, right? So now that is done, pretty much all you would have to do now is actually go up here and run test, but I'm not going to do that because I haven't run a test with the OpenZmeter actually on and configured. And really, if you want to run the test, my advice is to look at the spec sheet, consult it for its maximum current that can be measured, and also voltage. But then I would also consult the inventors and show them what ratios you're going to set for it, because there may be something on the software side you have to configure for that. So just keep that in mind, that's not an area we've gotten to. We've really just been, trying to figure out all this front side stuff. But that'll be something you'll dive into if you pick this project up. So that would conclude the software side of this, of simulating something on the OpenZmeter. Now we need to go to a place where we can see the results and what measurements did the OpenZmeter take. So let me pause it and I'll unpause and I'll show you how to do that. Okay, so now we're on my personal laptop, but it's connected to the same network as the OpenZmeter is over there. So I actually have a bookmark for it. You can see it's OpenZmeter, but it's also going to put the IP right there that it's fixed on. It has to be fixed IP. And I'm not going to show you the credentials because that'll be something I'll disclose to the incoming seniors. Okay, so I've entered my credentials. When it opens up, it may not open up and show you all of this information immediately, but it'll take a second and it'll load. Now, this is where it's showing you all of your measurements. You can actually look at energy consumption over time. It has waveforms for voltage and current, frequency, active power. It's also going to show you some summaries and reports as well. And you can actually go through here and click. This is the dashboard page we're on. You can go to Analyzer. You can look at the voltage, current, power, energy, frequency. Like let's look at power, for example. And it would record the transient playback from the IEEE ComTrade files. So you would see the measurements and the analysis that it conducts. And you can probably compare it to a device in the room, such as a Schweitzer brand, and see the accuracy difference in the measurements. That could be a very good area of focus for this. There's disturbances and alarms. That's something you could also mess with. You know, it's open source, so you can probably implement some new features to that. You got cost, heat map distribution, and then you've also got user settings. I've got my own account on here. But you just go into here, and it may be slow right now, but it'll show you your device up here. You can actually upload a pay rate for kilowatt hours, and it can tell you how much cost over time. And then you got user information down here as well, Wi-Fi settings, that kind of deal. But yeah, that actually concludes the setup and demonstration. And good luck for whoever picks up the project. It's a great one to work with. There are great people involved. And yeah.